Okay, hello everyone. Welcome to a session where we're going to talk about the Enterprise SDK that's supporting the utility network. Let's see, up here we have Alex. Alex, introduce yourself.
Hi everybody. Well, that's too late. My name is Alex. I'm been at Esri for approximately 3 years. I mainly work on the core geodatabase team under Eric, with a little accents on the utility network. Back to Eric.
Okay, I'm Eric Pohl. I've been at Esri since, God, evil grad school was over '97. Started when we started implementing the geodatabase back in April of '97. Okay, been there ever since, just doing C++ development. It's been a lot of fun. We've been concentrating a lot lately on the utility network, and we're going to be talking about that today. Now, quick question, is there anyone in here that is not using the utility network? Raise your hand. Okay, 20%, 25% of the crowd. So I presume you're here just to learn how to use the Enterprise SDK, because this is going to be very biased towards utility network consumption, or at least all the examples given. The rules and concepts, of course, they apply elsewhere, but we're going to be drawing upon a lot of utility network examples. Is there anyone in here that is not currently using the Enterprise SDK? Okay, so the remainder of you are actually already implementing SOEs or SOIs. That's okay. Very good. Well, anyway, we'll go through that today. Give a little bit of context and motivation behind all this and why you'd want to do it. And then Alex is going to take us through the actual API and how you consume the API to do some interesting things with the utility network. So we'll talk about what is the SDK. Alex will go over the API, and then we'll go over working with it. Now, big assumption, everyone understands the utility network information model. We're not going to introduce it, we're just going to be using it, okay? It's basically a network model intended for electric, gas, water, sewer, storm water, district heating, fiber telco type customers. Okay. Let's see, okay, utility network. It's running in the enterprise, on the enterprise platform. Namely, it is services-based. The utility network was our first data set that was implemented, new data set that was implemented to only be services-based. If you want to run a utility network in an enterprise environment, you run it against an enterprise server, okay? Now, some of the interesting things, of course, we implemented a collection of services to accompany the utility network. Building on the map service and the feature service, we added 4 other services. But with some organizations, maybe you want to implement logic on the back end. You want to do things, behind the REST API, such that it doesn't matter being in an enterprise environment, whether in the enterprise platform, whether your client is a heavy desktop client like ArcGIS Pro, is it a web app client going through JavaScript? Is it a mobile client? Okay, you can have 3 types of clients. You can, of course, have more, but those 3 main ones, either desktop, web app, or mobile. But you want to implement some functionality that executes, and you only want to implement it once. So that's why you would think about utilizing the Enterprise SDK. Put it on the back end, if you can manage it architecturally. Now, when you're doing that, how do you author your new functionality? Well, you would either implement it you can extend the REST API either through a server object interceptor, an SOI, that's a well-established pattern with ArcGIS Enterprise. And an interceptor, basically what you're doing is you're taking an existing call to an existing REST API, existing operation, and you want to override it or add some capability to it, add some of your own special sauce to it, okay? But it's an existing operation. That's what you do with an SOI. Versus an SOE, server object extension. Here, what you're doing is you're actually adding new operations. You're adding methods that do not exist through their current public REST API. You're adding your own API in there. Now, that being said, the ArcGIS Desktop, ArcGIS Pro, or web apps or mobile apps, the client applications there would have to have knowledge of that new API, because by default, they only have knowledge of our APIs that we expose through REST. So if you do augment the REST API through new operations, your client applications you'll have to augment the client applications to take advantage of them, okay? Because Pro doesn't know about your extensions. It won't know. But if you choose to enhance or override an existing operation made available through REST, that's completely fine. Let's see. There are two fundamental APIs that people use, .NET and Java. Let's see, what do we want to say? There's a little table there that talks about things that you can do with each and how they differ, SOEs versus SOIs and some of the different capabilities. You can read that at your leisure. There's a lot of good information out there if you want to just learn about the Enterprise SDK, specifically also with the utility network. I know Alex, who's worked very hard on that over the years with other people on the team, they've done a really nice job documenting it and providing lots and lots of examples utilizing these SDKs. So go and find them. They're quite good. Anything you want to add to that, Alex?
Nothing in too much depth, but yes, there's a lot of interfaces and classes exposed through Enterprise SDK for utility networks. I will show you deeper or later how to use some of them, but we'll get to that later.
They're pretty well documented. I think that's the main point that we're trying to make here. Okay, so we have a lot of different SDKs and APIs that are available to you to utilize and hit these REST services, these services that are exposed through ArcGIS Enterprise. You can use, going across the top, you can use the Pro SDK, the Pro Managed SDK, and do C# development. There are native map SDKs. This is used for your mobile environments. I don't know, there are 5, 6, 7 of those, it seems, somewhere in there. There's a JavaScript API for doing web apps. There's also a Python API if you prefer to use Python. And they all will communicate to ArcGIS Enterprise through JSON, hitting the same REST APIs, okay? Now, what we're going to be talking about is a little bit different. It's the Enterprise SDK that is utilized on the back end. It executes within ArcGIS Enterprise, okay? And it will be hitting the geodatabase, which sits on top of enterprise workspaces, which communicates in a client-server manner to an enterprise geodatabase instance, such as Oracle, SQL Server, HANA, whatever, Postgres. So we're exposing through the Enterprise SDK probably our richest APIs, ArcObjects level APIs, to interact with the utility network. What does that kind of mean? What's that doublespeak mean? Well, as part of the utility network, we do have a tracing framework, a trace engine, that's highly configurable and does a lot of stuff very nicely just through configuration. But through that trace engine, we don't expose a forward star cursor, so everything that you would do with the trace engine is through configuration. Now, maybe you want to implement a really tricked out trace operation or you want to be able to navigate through the low-level network index connection and containment information. Well, you can do that utilizing the Enterprise SDK, and some people have, okay? If you're really trying to do some tricked out stuff, the Enterprise SDK is very good for that. Now, let's talk a little bit more about SOI, Server Object Interceptors. Use interceptors to basically intercept a call, a web service request to one of the existing operations in the REST API. That could be on a feature server, like a feature service, like you want to intercept the call to apply edits. And you want to do some additional processing there. Or maybe it's an operation on the utility network server, or maybe it's an operation on the version management server, such as create version. Who knows? It's up to you. But a server object interceptor allows you to, before control passes to our functionality, you're able to do something. Hell, you can check things and you can return an error if you don't want to allow the operation. Or you can also do it as a post-processing step. After we're done with our default logic, maybe you want to add something on the end. Maybe you want to change the response. Maybe you want to write something to your own tables. You could do that through an SOI. So example use cases, one of the most common ones is fine-grained user access control. We were talking about this in the previous session. Say we had a system, we had an organization that wanted to lock down where a given user can edit the data in their database. We have a database, we have a geodatabase, a utility network that spans all of California. And let's say Alex, he's running for this electric utility that's utilizing this geodatabase. He runs the Palm Springs office. He's the manager there. And Alex is able to do any edits he wants in the Palm Springs area. But the electric utility company says, well, that's the extent of your knowledge or capabilities. We don't want to let you edit in downtown LA or San Diego. And maybe I'm the guy in San Diego. I'm perfectly knowledgeable about what's going on with my electric utility in San Diego. And I'm the manager and I can make whatever edits I want. But I should be disallowed from editing in Palm Springs or any other place, okay? So this electric company, you could implement an SOI that could put in fine-grained user access control. So every call to apply edits, you know the user's credentials, you know whether it's Alex or Eric, and you can see where the edit is being attempted. Maybe Alex is trying to edit something here at the convention center. Your SOI would go, hey, thumbs up, you queried your database, it said Alex is allowed to edit in Palm Springs, let the edit sail through, okay? Hand it back off to the regular apply edits functionality. You're done. You've intercepted it and you're gonna let it pass on through. Whereas if maybe Alex is trying to edit something in downtown LA, it goes, wait a minute, this is outside the extent, the permissible extent for Alex. No, return an error. Do not let that apply edits call go through. I'm returning saying, no, not so fast, okay? That's fine-grained user access control. Heck, you can do it at the field level, you can do it however you want. You can imagine what you could do there. Maybe you want to put in some auditing, custom auditing or notification functionality. Okay, we could do that. Data filtering, enrichment, maybe additional validation, additional checking of things in the course of doing an apply edits operation or some other operation that's exposed through REST. Maybe you're doing version management, and if you go and want to post data to default, your organization wants that logged somewhere. You want an email sent to someone whenever someone posts some new information to default. You could set up a system that would do that and you would implement it through an SOI. So you kind of get the idea of what an SOI is intended for. So here we see the client apps on the left talking to the REST APIs. You implement your SOI that sits in front of the map service or the feature service or the utility network service or whatever other services. And you get to intercept the call, okay? And decide what to do with it. And there's a whole lot of good doc available out there on that. So this is back to is editing allowed? Well, you can see the client sending the call to apply edits. Your SOI is saying, are the edits allowed in the area? If they are allowed in that area, you forward the call on to the feature services apply edits operation, then the response goes back to the client. If, however, the call to apply edits, you were trying to edit something in an area that's disallowed, just return an error, okay? Kind of see how it works. It's pretty straightforward. Now, the other side of the coin is the extension. Not the interceptor, but the extension. With an extension, you are creating your own REST API. You are extending the REST API with new operations. And because you're extending the API, it's a new API, you're going to also have to extend your applications. Either you're writing custom applications, maybe you have a custom web app that knows how to hit your new operations, your SOE operations through the REST API. Or maybe you put a new tool into ArcGIS Pro that's making a raw REST request, a raw REST request off to your new API. You can do that as well. Do it through Python, do whatever you want. Now, examples here, a custom tracing operation, something that is not done through configuration of the trace engine. You're adding a whole new trace, maybe just does something completely different that our framework or engine cannot do. Maybe you'd like to be able to have a new way to export data on a regular basis, exporting a subnetwork in a crazy new format, something that we don't support. Maybe, we export stuff in protocol buffers and JSON. Maybe you have your own organization's tricked out format. Okay, so you could have a different operation that does it your way, okay? So these are things that you can do with an SOE. Add in your own completely new functionality. Here we show a graphic that shows Mansour is being pretty loud next door. He's a very energetic speaker. Everyone know Mansour Rod? He's really loud. Great guy. So here we see the apps, the generic apps that we have that are going to be talking to the ArcGIS REST APIs. And those REST APIs are, of course, things that are exposed through map services, feature services, utility network services, version management services, sort of our stuff that goes and hits the back end. Now, if you have your SOE, it has a new API, a different REST API that the generic apps, our generic ESRI apps, are unaware of. So it'll have to be your custom client code that's communicating to your custom API, okay? Should make sense. It's not a real hard one to understand. And just like the SOI, there's some really nice doc that talks about it. Here's the thing, we can see your custom client application calling your custom operation that hits your REST handler, your server object extension. It can do the custom trace, and then doing the custom trace, maybe it hits the enterprise geodatabase and the utility network index, churns through it, and then responds back. But that's very different. That's the different pattern that we saw from earlier with an SOI. Okay? So, how do you do it? Well, okay, there's a lot of good stuff that you can read about how to do this, some samples on how to do it. Quote it up, you deploy it, then you go and enable your SOE, then you just start testing it. That's the basic story, not a hard one. Now, doing the actual work and implementing it, that's another story. But conceptually, it's pretty simple and understandable. So, Alex.
Right. Okay.
Do you want me to go tell Mansour to
bang, bang.
Yeah, I'll just bang with a shoe on the wall.
I wish, but no. So now, I just want to go through some of the available APIs that we have with the utility network and how you can use some of them. So before we get into that, there is something that we have created. It's called an object model diagram. It's basically a schematic graph of how you can traverse from using one object in the utility network to another object. As an example is, let's say you have a interface called iBase network. How do I access the interface iDomain network from iBase network? You can follow this object model diagram, and it'll show you arrows and relationships to how to get there.
Very quickly, are there any old ArcGIS developers here in the crowd? Okay, you've seen these diagrams before. We called them the OMDs. We started putting them out at 8.0. They're really useful. That's what you put in your hallway or in your office. Hang them up. They're really, really useful. It's the roadmap to programming the system. So we've done that again with this Enterprise SDK. Alex has.
Yes, in our office, we have a giant E-size sheet that you can print out and just paste on your wall or whatever. So that's one way you can use it. You can even show it off, or like, for example, in our office, we can have like see-through windows. You can hide if you're on a call, but it's not what you do.
That's not the intent. But
Don't really do it.
now, don't click on the QR code. I think it takes you to a Gilligan's Island fan site, so don't go there.
Yeah, the QR code, as Eric said, yes, it takes you to the OMD, so you can scan it if you like. You can also, it's kind of hidden inside their documentation, but I'll show you at the very end how to get there. So yeah, this algebraic diagram shows you all the interfaces and how to traverse between one interface to another. There's a lot of them, like over 100. In utility networks, not over 100, but overall, out of all our software, there's a lot. And there's also an SDK guide on our documentation that you can look through to see how to work with utility networks as well. Now, I will walk through this diagram in small parts. It's kind of big, so we won't do it right now. So what can you do through the Enterprise SDK? So like what we can do through REST, we can see the data element of your utility network. The element contains a lot of information about it, about the network, such as your domain networks, your associations, your network sources. We can access all of that through the Enterprise SDK. So information like associations and tracing right here. And before we go through APIs, there are some functionality that are not available through Enterprise SDK. Those functionality include DDL. You're not allowed to create a utility network or modify the schema, so modify the tables and information, stuff like that. We have another SDK called the Pro Manage SDK. You can do DDL information through there, but you can also not edit or do DDL on a utility network. So that's kind of standard throughout all our SDKs. And we also do not support bulk loading as of this time.
And that, why? It's just we haven't gotten there yet? Why don't we support bulk loading through the SDK?
Yeah.
What? Speak into the microphone to the crowd.
Oh.
I don't
My
care.
voice loud enough?
They.
But yeah, we don't support it at this time, but we should.
Will we?
I would say I hope so. I can work on that.
Good answer.
So moving on, we have some interfaces. I'll just show you some examples right now. One interface that we have exposed within the last 2 years is iNetwork trace configuration. Now, for traces, trace configuration basically defines how to run the trace. And we also support named trace configurations, or which is ways to persist certain trace configurations that you have created. So this is really good for reusing. You don't have to enter in the same information over and over. You can just save it as a network trace configuration, fetch it, and then reuse it. And some more interfaces that we have are iBase network location, where you can work with non-spatial objects, the capability. Some more interfaces that we expose is iBase network association. This allows you to work with associations, like add connectivity associations, for example. You can add, you can delete associations, and so on. You also traverse, which is a really neat feature to go through all the associations from a certain element, or associated elements from a certain element. And we also expose I-based network topology, which is what you will use to rebuild your network index. So your utility network, to basically, once you make an edit, you can update all of the element spaces of that, of the utility network. Now let's go to working with the API. So the first question is, how do you get the utility network? So I will show that later in the demo, but the utility network itself is an object that implements the iDataset interface. Once you get the iDataset interface for the utility network, you are free to traverse the OMD as I showed before. You can go through all of the interfaces. For example, IDE-based network to access data element, or check the iDomain networks, and stuff like that. But you need to first get the iDataset for your utility network object. So there are two ways, or there can be two ways of doing it. I'll show a better way in my demo. But one way, if you know the name of your utility network, you basically start off with your map server first. And from your map server, you can get the first layer, which will belong to utility network. So you can get like a feature class, for example, the dirty areas feature class. And from there, you can get the feature data set. And from the feature data set, we can retrieve the utility network. This is one way to do it. This requires you to know the name of your utility network. But if you don't know the name, there's a maybe simpler way, but we'll get to that later in this talk. So for example, once you have your feature data set, you can cast it to an iDataset container and use dataset by name to fetch your utility network. So now, let's say we have our utility network. We can cast it to I-based network, and we can basically run from there. There are a lot of interfaces you can cast to, and you can also do a lot of functionality from that point. So in this example, we have the UN dataset, iDataset object. We can cast it to I-based network, and we can use all the available interface casting that we have.
Is everyone familiar with our ghetto UML that we're showing up here? Just showing a little bit of inheritance and all that. OK, good. That's what those little arrows mean. The utility network has access to network core as well as base network and all the interfaces contained within.
Right. And as I alluded to before, the data element is something you can use to get information about your utility network. So example, the domain networks and network sources. What we want is the IDE-based network object. And I'll show you how to get that in a little bit. But as you can see, you can access certain information from it, like domain networks again, and tiers, and asset group, asset types, which are very important if you want to work with. And again, here's a subset of the OMD, but large information will be shown later.
The data element constellation is basically all the metadata surrounding the definition of the utility network instance. The utility network is a very complex data set type, and so it's highly configurable. So you'll see a large collection of classes, components, and abstractions that are configured as part of that data element. So that's the reason why. If you're looking at a simple feature class or object class, of course, it's much simpler. But with a utility network, it's a fairly aggressive data set type, so the data element itself can be quite complex.
OK, now we get to accessing the data element. So in this case, the code snippet on the bottom right, your UN dataset, your iDataset, is very straightforward to get the data element. All you need to do is cast it to another interface that we have. It's called iDataset component. And then from there, you can directly access that data element, as shown right here. So now that we saw a data element, let's say we want to run a trace, for example. In this case, the base network is your iDataset for your utility network. It's just casted to an iBase network. All we need to do to run our trace, we'll cast it to an iTracer. We need to create a utility network query, and then we'll initialize the tracer with a query and a data element. From here, we can run any kind of trace we want using tracer.trace. But as you can see down below at the bottom right again, this is the available methods of the iBase network interface. So create query and create tracer, those will be used to get your tracer and initialize your tracer. Moving on. Once we have our tracer, let's say we want to run a trace, right? We have to configure the trace configuration for our tracer. So the first step we need to do, we need to tell the tracer where to start tracing. We need a starting point. The starting point is going to be a GUID, or the global ID of your feature. So we need to get the starting GUID. In this example, it's going to be a junction feature. So then we just add a starting point as a junction. We add the GUID and a starting terminal. Then we configure the trace configuration. We add all the properties that we need. For example, include barriers or validate consistency or domain networks. We can add them on this trace configuration object. And then from that trace configuration object, we just store it on the tracer, which is the tracer at the very bottom. It'll be the tracer configuration property. We'll store it on the tracer with that API. So now, the top line is how you execute a trace. In this example, it's a downstream trace, but that's the API you'll use. Execute it. And once you're done executing it, you're going to use a new interface called IU and trace results to fetch the information of your trace. So trace junctions, you can see the global IDs of junctions. You can see the asset groups of all trace junctions and edges. And that's the way you can use it right there. So now let's show you guys how to query or go through the network index from the Enterprise SDK. So a quick overview is there's two separate spaces for your utility network. There's a feature space and the index space. Feature spaces are your line feature classes, point feature classes, and so on. These could be like device network sources as well. And the network index space is all your elements and associations that we have. For your feature classes, so let's say you have a device point feature class, it maps to a single network source on a network space, so yeah, device network source. And each feature within the feature class has a one-to-many ratio to an element. So one feature can be represented by multiple elements. For example, a line feature can be represented by multiple edges. On, now that we have the diagram out of the way, there is an interface called iUtility Network Query. You can use this to traverse your elements, basically. And to get the utility network query, it's essentially the create query object on your base network. So now, let's say I have a feature that I want, and I want to get the corresponding element for that feature. To do that, once we have our iUtility network query object, we can run the elements method, pass in our starting GUID, and then we get the resulting elements for that feature. You also get information about the EID and the element type.
Do people know what an EID is? We're using terms that you may not know what they are. An EID, let's back up a little bit. The network index, what we've done is we talked about feature space and we talked about index space. The network index is nothing more than the network topological primitive representation of feature space inside effectively a graph. The primitive elements within the graph are called network elements. They can be of type junction or edges, okay? Now, each of those junctions or edges, those network elements, has an identifier, which is colloquially termed an EID, an element ID. It's just an integer. And that's how we do a lot of our manipulation in the back end. We're just walking through integers that are representing either junctions or edges in this graph representation, okay? That's what an EID is. It's just an integer pointing to a primitive inside the graph.
Now, moving on, if you have your element ID, the EID, you can also query adjacent elements to it. So let's say I have a starting junction element. I want to get the connected edges to a junction element. I can use a query adjacent edges junction method to get the EIDs for those edges, essentially. As you can see, the IUtility network query class or interface is fairly large. There's a lot of methods you can use with it. Now, let's say I want to get associated network elements. So, for example, I have a junction element. I want to get another junction that it contains, in containment associated, for example. I can use the IUtility network query association interface. APIs, so for this example, it'll be the containers API. I'll just pass in my EID with an element type, and I'll get the containers for it.
For those of you that are old ArcObjects programmers, what it's doing here is essentially all that forward star cursor stuff that you've done already on a geometric network. It's basically our cursoring mechanism through this graph.
Right, it's essentially very similar to the ArcObjects programming. And in addition to C#, there's also the Java version of the Enterprise SDK. There's some slight differences with C# and Java. For C#, you can directly use I-based network. But for Java, you can't because we haven't exposed implementing class for it. So you have to use what's called a proxy class, I-based network proxy. It works exactly the same way, but you have to add this new identifier to it to use it through Java. But that's the only difference between C# and Java. All the APIs are the same. You can use it the same exact way. You just have to be mindful of this proxy key. Right, now let's go to a quick demo. Show you guys how to use it. So I'm going to show you a quick demo using an SOE, a service object extension. So once we have the program, all you need to do is open Visual Studios, and you can access that template, and it basically generates all the classes or the class and all the methods you can use with it. So this is a very general example. My SOE is going to be it's going to be a custom trace SOE. What it's going to do is it's going to perform a downstream trace given some parameters. And just for added bonus, I'm also going to show you how to save a trace configuration that you have, a name trace configuration.
So you're doing an SOE that's just doing a downstream trace.
Right. It's very simple implementation of the SOE, but I can show you
Okay, so one thing that's important to realize is although the generic tracing engine and framework provides this capability already, Alex is sort of re-implementing it to show the pattern. Right. Okay, you don't need to do this because we already support this, but it's showing the pattern that you want to follow.
Show you guys how to use the API. So when you create the project, it'll give you this class essentially, and this class is all you get. So you'll walk through all the methods real quick, high level. So the first thing you see is the constructor. There's not much you need to do with this constructor. Leaving it as is perfectly fine. We don't need to touch this. Moving down below, it also gives you an init method. The good thing about this method is if you want to debug your SOE that you created, you can launch the debugger at this step. So once you load your SOE, if I have this uncommented out, I'll start the debugger, then I can walk through my SOE in debugging session. Just a key point, just do not leave this commented if you're deploying it, because it'll try to launch a debugger every time a user tries to use it or load it. But in this case, it'll be commented out. It's also a shutdown function. We don't need to make any changes here as well, but you can. Let me just compress everything. So now, how the flow goes through the code, the SOE starts at the init function, and then it goes to this construct function. This function right here is where you do all your initialization for your SOE or SOI. In this case, sorry, it's kind of loud. In this case, I have my utility network. I'm going to try to get the utility network at this step. So before, these 4 lines right here, these are how you get your map service. And from your map service, you can get the map layer infos, which is essentially each layer inside that service. From this point, we can eventually find our utility network layer. So in my presentation earlier, I showed you a method to use if you knew the name of your utility network. In this case, I will show you a method to use if you don't know your name of your utility network, how to find it, essentially. So how to do it is actually pretty straightforward. All you need to do is loop through all of these layer infos, and you are going to search for the type utility network layer. Once you find a layer with this type, that is your utility network layer, essentially. We just now need to get the data set out of it. So this is just code to show you how you can log information. So let's say I cannot find my utility network layer for any purpose. You can use our logger to print a server log. So in this case, I'll just print fail to get the utility network layer if I can't find it. Right? So this is just diagnostics. Once we have our utility network layer, to get our data set from it, we'll basically just use the server object given, the map server object. This is given in the constructor of your SOE by default. And we'll call the get data source API, and we'll pass in the ID of our utility network layer. And essentially from there, that's how you get your utility network. We don't need to know the name or anything, and it's pretty much straightforward from there. And again, this is just validation. It's good to have some exceptions to print logs, server logs, to see if anything goes wrong. There's just extra checks for that. So now that I showed you how to get the data set, let's go to the next function. There will be IREST requirement layer members. We don't need to make any changes here, so you can ignore them for now. Another crucial part of the SOE is creating the schema of it. At this step, you can add properties to your SOE. So for my case, the standard is the template just gives you 2 of them. You can add more. So essentially, if I pull this up real quick, these properties correspond to these values, essentially. You can add as many fields as you need for your SOE. You'll do it right here. And that's all you need to know for that step. Let's move on to the next one. This is the define information of your page. In this case, I just print a name, description, the version, whether or not it's a valid network topology, meaning I have enabled the network topology or not, and this information I'm printing out here. And from there, this final function that you have, this is the meat of your SOE essentially. This is where I define all my logic that I want to implement essentially. So these steps come with the template as well. These are just to get all the individual inputs of your extension. So you can ignore these steps. And then from there, for my data set here, this is where all the logic comes in. So in my case, I'm trying to create a tracer that does a downstream trace and then save the trace configuration. From there, this is where all the information happens essentially. You have your I-based network, you cast it, you create your tracer at this step, this is your network query, and here's where you initialize it. And from there, it's basically just a lot of extra code to run it, but get the gist of it. This is the trace configuration, this is setting up your starting point, and this is running the trace. And from there, you also have a response. That's what gets shown after you run the endpoint. There will be a response object. It's a JSON object. You can include any information that you want with this object. So for example, I can include status and print it out to the user, whether or not succeeded. And there'll also be more later on, but let me get through this step, another step real quick. This is an additional step that I chose to add. It's actually just adding the trace configuration. What I want to do is just essentially from my base network, I'll use the iNetwork trace configuration object, and I'll just add it with some name, essentially. That way I can use and reuse all the time I want. And as you can see right here, this is another good interface object or method to use. This gets all the traced objects that you have. So your trace that you ran, I want to get all the OIDs of the junctions and the edges. This API gives it to you, and it'll basically print it out right here, and you can access it from there. So yeah, the final step is just formulating a response. So in my case, I want to show all the junctions and edges, and input success if it succeeded. And again, add in the logging information in case it fails. But that's the gist of the SOE.
Hey, Alex, is that code shared somewhere?
At this point, it's not, but we can share it through the Dev Summit.
Yeah, please. I think it might be useful if people would like to use that as a starting point, because there's a lot of stuff that you have to.
Yeah, it's a lot of information, but again, a very helpful tool to running through all these is using the OMD. So yeah, if you have the OMD, you can start the I-based network. Let me show it to you guys, or a smaller. So it's kind of hard to find, so I'm going to show you how to find it. So the best way to find it is to type in ArcGIS Enterprise SDK Utility Network. And it'll be the work of utility networks link. Scroll down a little bit, and the OMD is going to be right here.
That's terrible.
Yeah. It needs to be improved. And once you have it, this is essentially it. You can see all the available methods for IDB-based network and your base network from here. This is your base network. And all the stuff that can cast.
We need to make it more discoverable.
Yeah, we definitely need to make it more discoverable. It's hard for me to find as well, which is really bad. But essentially, yes, once you create your SOE and you're happy with it, you just build it real quick. And once you built it, the place to find the SOE, so let's say this is my solution, right? You go into your binary folder, bin folder, not binary. And you'll find it inside the debug and net 6.0, whatever .NET version you have, and it'll be this file right here, ENT. Once you have this, we can use this to deploy on our server. So in this case, we'll go to our ArcGIS Server Manager. We'll go to Site. We'll go down to Extensions. I already have it included right here, but you just add extension, choose your file, and add it right here. So this is how you add your SOE. And how to load it into your server, we'll go back to Services. We'll go down to the service we want to load it on. Go to Capabilities. Go to Find It Here. This is the name of my SOE, for example. I'll check it, and now run Save and Restart. I'm not going to do this here because save and restart takes a while, but these are the steps to deploy on your service. And yeah, I would show you how it runs, but ever since I came here, the server was not behaving correctly. So I can't show you it, but essentially if you want to find it, it's essentially, this is an example service. You're going to find it in your map server. You scroll to the very bottom, and your SOE is going to pop up right here. And you can run it from there. Right. And that is my basic or very general way to start intro of creating an SOE. SOIs will be very similar. There will be a different template, however, and you can load it. The loading process is a little different, but it is very straightforward with the docs. Right. Okay.
Okay, I think we're basically just about done. Thank you, Alex, for walking us through all that. We will make sure that the source code that Alex was taking us through is available to you guys after the Dev Summit. Got to sort that out.
Yeah.
Okay. Okay. Now, in this presentation, hopefully you have a better idea of some of the motivations behind our platform and our service-based architecture, why we did it. Given that we have a service-based architecture, how do you extend it? We showed you the two basic patterns. Either you're going to intercept existing operations on the REST API and do something, such as preventing edits in unauthorized areas. Or you can extend it, such as what Alex was showing in the source code, where he actually created a new operation that then your custom client application code would then need to call into. But these are the two patterns, the SOIs and the SOEs, and hopefully it makes a little bit of sense to you what the differences are and when you do use one or the other. There's a lot of online doc inside ArcGIS Enterprise independent of the utility network talking about all this stuff. I guess you can find that pretty easily, easier than you can the OMDs. There's a lot of good stuff there. And other example projects and whatnot that you can download that'll help bootstrap the process should you want to go there and do this. Let's see. And the nice thing about the Enterprise SDK and doing things on the back end first, it can be very powerful from an architectural perspective when you look at your platform story and you're hitting it through desktop apps like Pro, mobile apps that are connected, or even web apps. Okay, that's pretty cool. But it also gives you access to a finer grained API or SDK than you would normally get through Pro. If you use the Pro managed SDK, for example, you do not have access to the lower level APIs necessary to walk through the network index. You don't have that. What you do have is the ability to configure and utilize the trace engine. Why did we do that? Why do we only provide fine-grained access to the network index through SOEs or SOIs in the Enterprise SDK? Well, think about it architecturally. What if you wanted to implement your own custom trace on the client side in Pro? Well, okay, you grab the network index. Then you grab your first network element, a junction. Then from there you say, okay, what am I connected to? Well, in order to resolve that, the database and the network index is on the back end. That would require a REST call if we chose to expose it. It would go through JSON. It would go hit your enterprise, hit your service. It'd be deserialized. It would then go into the geodatabase, into the utility network, in the network index, and say, oh, this junction element is connected to these three other junction elements through these three edge elements. Package it up, serialize the response, deserialize it on the client side, then provide it to you through the Pro Managed SDK. Could you imagine doing a trace any slower than that? That's horrible. All that infrastructure you have to go through. It's not like you're on the back end and you're just hitting these hot binary network index tables and things are fast as anything. That's why we chose not to expose these low-level navigational capabilities of the network index through the Pro Managed SDK or through the JavaScript SDK. It only makes sense architecturally for an enterprise SDK where you're already on the back end. You already have access, direct access to the network index. That's why we do it that way, okay? Now, that story may change in the future once we complete all of our work on replicating utility networks and supporting bidirectional sync, okay? You can do that for the mobile arena, where you could say, okay, I want to take a portion of my utility network that's been published, I want to take it offline. So I create the replica, then I put it on my mobile device. Then I can do all my stuff on my mobile device when I'm disconnected from the network. Okay, that's pretty cool. And periodically resynchronize. Okay, that's cool. But what if you instead, you took that mobile geodatabase containing the utility network that you created through the replica and you put it on the desktop that has Pro running? Then you do have the network index local inside Pro. And then it might make sense to extend the Pro Managed SDK to allow you to have direct navigational capabilities inside your network index. Feels like I'm watching someone in New York City in the 1930s do three-card monte, all that gobbledygook I just said. But at some point when you do, we'll expose things when it makes sense architecturally. Right now, architecturally, it only makes sense to expose those types of capabilities on the back end. So that's why we do it. In any event, there's lots of good material available online for learning more about this. Good sample code. Alex will be sharing his sample that he walked us through today. And hopefully we've clarified a few issues for you. If you have other questions, come on up. First, thanks for coming, and I hope you enjoy the party tonight. Apparently it's Thursday today, right? Okay, pretty but windy day in Palm Springs. Okay, any quick questions? Yes.
So this one's a broad network question as well. If I'm trying to do some network export, is there any way to get related objects as part of that export? And then I guess if the answer is no, that kind of sounds to me like an SOI implementation.
Yes. Yeah, that's an interesting question. That's actually a good use case. Interesting. Interesting. Okay, we already support export subnetwork. Maybe you're not trying to change the format, but you want to include more stuff to be returned with that result when you're exporting the subnetwork. Could you then augment that collection of stuff flying back? Yes, you could through an SOI. That's an interesting use case, actually. Good question. Okay, we'll call it done. Oh, final question.
Quick question, when you're customizing the apps, what SDK would you use to customize an app to interact with the SOEs?
How would you do that, Alex?
I'm sorry, repeat the question.
He's using the Pro Managed SDK. How can he access one of the new methods he created through a server object extension?
As of this time, I don't think the Pro Managed SDK can access it. I'll have to check with you though.
Can't you make a raw REST request?
You can, but we don't expose the REST request. You have to use a separate method for it.
You have to what?
Use the Windows API that comes with it.
So there is a way there.
There is a way to access REST or call REST request through the Pro Managed SDK, but we don't have any specific.
We don't have a custom way of doing it, but it is available through the SDK as part of the default infrastructure.
Okay, so through the Enterprise SDK itself, you can customize the apps?
No, not through the Enterprise SDK, only through the Pro Managed SDK can you customize the app. This Enterprise SDK is only for the back end, not the front end.
Yeah, okay.
Okay, anyway, thank you guys. I hope you guys enjoy the party tonight.